Hello, everyone, my friends, my viewers at home. Uh, Today, again, we are right here on your screen just to make you smile and make life much more easier for you with our chemistry epic videos that we are dishing out. Now, as we promised earlier in our previous video on Lewis structure, today we're going to be working on strictly on the examples that are to be old. So I'm going to be working strictly on examples, how to draw them, and so many things about them will be revealed today. Now we move straight away to what you can see as the headings for the class, which is what? Drawing Lewis structure of molecules and ions. And the examples here that with these 7 examples that we'll do right here on the board, we all should be able to draw any Lewis structure, and from the Lewis structure we know so much about them. And said draw the Lewis structure of the molecules or ions below. The first one is methane, we have ammonia, we have carbon 4 oxide, we have sulfate, we have boron trifluoride, we have hepta iodide ion, the nitrate ions. So we work with the first one, which is so the first one, example 1, as you can see, for CH4. How do we go about it? We ask ourselves first question, the magic number. And the magic number for methane is A. As I've told you earlier, is step 1. Carbon is 4 plus hydrogen is 1 times 4. Everything gives me 8 electrons. Remember, I've told you earlier that the A, which will be the magic number, can also be called the available electrons, and as the case may be. Now we'll move straight away. Now, the step 2 is that we should be able to identify our what now? Our apparent or central element. And from here, the central element here is carbon, because it occurs the fewest and has the highest oxidation state. So, step 3, as we said, that we'll bring out the central element out, then spread the other atoms around the carbon. As you can see, hydrogen, 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 hydrogen. Then the electrons are spread across all of them too, meaning the atom the atom, the other atom with the central element is connected with, first of all, a pair of electrons, as you can see. Now remember that hydrogen and helium obey the duplet rule, while all other elements, precisely for element in period 2 and thereabout, they obey the octet rule. Duplet 2, octet 8. So as you can see, so hydrogen here is already completing its duplet rule. And then one duplet. Now if you look at it very well, look at the shortcut here. The shortcut is that the available electron, which is the magic number, is always equal. It must be equal to the surrounding electron. And here is 2, 4, 6, 8. I think it was less than. I think what we have here was less than. It therefore means that the other one will now put it on the central atom. So here now is complete. Here I'm having 8 electrons. Here I'm also having 8 surrounding electrons. Is that clear? So move straight away to example 2. Now for example 2 here, of course, for ammonia, the magic number here is nitrogen is 5 plus hydrogen is 1 times 3, which will give me 8 electrons. Is that clear? Now we move straight away to we bring out this nitrogen out, which is nitrogen, which is the central atom, then hydrogen here, hydrogen here, hydrogen here, then a pair. Now observe, hydrogen here is already completing its duplet state or duplet form. But now let's check. If I'm having 2 plus 2 plus 2 is 6. Is 6 because we were told that you distribute the other atom around the central atom, then a pair of electron, a pair of electron is used to link the nitrogen with each of the atoms that are involved. In short, like I get nitrogen for here, and the other one hydrogen here, hydrogen here. That when you go connect this nitrogen with other elements, it will be first of all a single, that's the first step, single bond first of all will be spread across them before afterward you now share two. Remember that 2 electrons what forms a bond, so 2 4 6. Is it up to this magic number? No. So it means that 2 electron which will form a bond is left, so that 2 electron we will now have to put it on the central atom because they ain't remain. So that as it is now, I'm now having 2 4 6 8, which is now equal to the central to the magic odd number. It's clear. So move straight away to the next what? To the next example, which is stealing. I'm having CO2. Magic number here is A. Carbon here is 4, plus oxygen here is 6 times 2. That's 12 plus 4. It give me what now? 16 electrons. Is that clear? So move. Let's do it. Now look at it. I'm having carbon. Carbon will be the central atom. Of course, you are aware. Now I'm having oxygen here. I'm having oxygen here. Now, put it a bond, put a bond. Now, I will have to complete the other atom to be octet. That's the rule. That all other atoms, apart from the hydrogen and helium, which are already in their duplet form, all other atoms will have to complete them in their octet form. All other atoms, not the central one first. Now, the other atom, you spread the electron to make them to be complete. So here 1 2 3 4 5 6. So these 2 8. So this octet rule obeyed. Move to the next one. 1 2 3 4 5 6 7 8. So it's obeyed. Now look at it. 8 plus 8 is what now? Is 16, which is the same thing as this 16. But we now have to ask this question: is it possible for, because carbon here is not completing its octet form yet, even when the magic number that we are having here of equal to the to what we have just done. But look at the shortcut here. It's a rule. It's a shortcut. That when an atom is having a valency, not valence electron now, a valency of +1 or -1, that atom can only form a single bond, which is like this. But when an atom is now having +2 or -2, that atom can form either a single bond or a double bond. If it's now having +3 or -3, it can also form either a single or double or triple without affecting anything. So it means that for us to now make oxygen now is having the oxygen has the valency of -2. So there's every possibility that oxygen here can as well pair is low pair to make this carbon here to be in its octet form from both sides. So what do I do? So I can as well rewrite it to be that carbon double bond O, that's carbon here, carbon to oxygen, carbon to oxygen. This one here will come here, this one here will also come here. So I'm now having 1, 2, 3, 4. 1, 2, 3, 4. So check. So 4 plus 4, oxygen here is still completing its octet form. This other oxygen is also completing its octet form. This carbon here now is not also completing its octet form, meaning we are balanced in our life. That is our. So this one now is done. All right, move to the next question. Move to the next question. All right. So we move to the next example, which is example 4. In this case here, follow me. We're having SO4 2 minus. Okay. Now, magic number again, sulfur is 6 plus oxygen also 6 times 4 plus 2, which I've told you negative, so that is gaining. So everything here becomes as 6 as 24, as n becomes 32 electrons. Now, the central element here will be sulfur. Now, so it means, so the way to do this one is, so why the charge will be up. So this is how we do it. So I'll put it in bracket, it's in parentheses. I'm having my sulfur here, it's the central atom. I'm spreading this other oxygen around it, around it, around it, around it. But by these 2 minus here will come up here. That's how you do it for all other examples. Now, single bond first. I complete the octet for other elements. So let's check. Now, I'm having 8 times 4 to give me 32 electrons, which is, of course, is equal to this 32 electron. Now check. The sulfur here completing this octet rule. Yes, 2, 4, 6, 8. So this one is balanced. This one is very much okay. Move to the next one, number 5 here, which is boron trifluoride. Now for boron trifluoride, this is BF3. For BF3, having the magic number here to be boron belongs to group 3. So which the valency is, the valence electron here is 3 plus fluorine. Valence electron is 7 times 3. That's 21 plus 3 will give me 24 electrons. Now bring that boron out. Put the fluorine here, fluorine here, fluorine here. Now a single bond first, then here, here. Lewis dot diagram. Now, if you do it this way, 8, remember that here is, each of them here is 8, 8, 8. So 8 times 3 is 24, which is equal to 24 what now? Electrons. Now I ask myself this question. Is it possible? Because if we check this one here now, for boron is not completing its octet state. But are you also aware that I have told you earlier that if the valency of an atom is -1 or +1, it can only form a single bond. And because it can only form a single bond, which is what you are seeing here, we cannot remove. No, it's not possible. It's not possible. So we allow it to remain in this format. So we continue to number 6, which some persons will see it to be very, very difficult, but with our rule that we have obeyed, and there's no problem there. So we continue to this number 6 as is I7K. Magic number. I will have the valence electron of 7. 7 times 7 plus 1 as 49 plus 1 is 50 electrons. Now what do? I will make one of this iodine atom a central atom. Here becomes iodine. Then I put iodine still. I just spread it around. Just spread it around. 1, 2, 3, 4, 5, 6, 7. So put a single bond all around it, and I put it here in bracket minus. So there is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So yeah, I'm having as 6. 6 times 8 will give me as 48 electrons. 48 electrons. It means that one electron is left. So I put here to make it to be 50 electrons. All right. Okay, so after what you are seeing, if you observe now, look at them so far. Remember, ID belongs to group 7, and the valency it can form is just is -1. So it can only be single bond. I hope you are following what I'm doing. So that in case you have any question, you can always drop your message in the section below, and I'll give you immediate response. So move to the last one, which is number 7. 7. Now I'm having NO3. So N here, magic number is 5 plus oxygen here is 6 times 3 plus 1. That's 6 times 3, 18. That's 18 plus 5 plus 1. Give me 24 electrons. Now I come here, nitrogen here, then I take the other oxygen, then put it in bracket, minus, here, single, here, 1, 2, 3, 4, 5, 6, 1, 2, 3. So here we come 8 times 3 is what now? 8 times 3 is 24 electrons. But we can as well ask ourselves some questions. Can oxygen form a double bond? Because we check this nitrogen here now, it's not completely its octet form. So I cannot fall back here. This one that I'm having here now, can any of the oxygen here form a double bond here? Yes. So I can as well just simply say that nitrogen, okay, 1, 2, 1, 2, 3, 1, 2, 3. Now, and on that very note, one can be able to know what we call the bond pair and lone pair. Bond pair and lone pair. Please take note. Bond pairs are involved in bonding, while lone pairs are not involved in bonding. Now, question can be asked: how many bond pair on lone pair do we have for the central atom? Let's say for boron now, you can as well say that the number of bond pair here for boron is 3. But then in lone pair, no. 1, 2, 3 bond pair, no lone pair. For iodine now, as I said, for this central atom here, is there any bond pair here? Like how many bond pair? 1, 2, 3, 4, 5, 6. That's 6 bond pair. How many lone pair? Just 1. I move here for sulfate. Is there, for the central atom, which is sulfur here, is there any bond pair? Yes. 1, 2, 3, 4. Was there any lone pair? No. So with that, you should be able to get a wide understanding of what you should know. And on that, we are done with this video. Next time, we will work on other videos. For as at now, God bless you.